Hey, second period. As we discussed last week, I'm not going to be there with you today, but I will be back tomorrow. Um, I hope everything's cool in the classroom today. I hope everybody's able to just kind of focus and bring their best selves. We're going to continue practicing the same algebra stuff we were working on last week, which those of you that were in the classroom toward the end of the period on Friday started doing really well on this, but we were kind of rushed on some of it at the end, but I did start seeing some really good stuff. Some of you weren't really here when we were doing it together in that period on Friday. And so for some of you, this is going to feel maybe a little bit more new. But regardless of whether you were here or not, I'm really hoping that you're able to follow along with this, completing the worksheet that should have got passed out to you. Let me share my screen so you can see it here. Where is it at? There it is. There it goes. Okay. So you should have this. My goals for you for today's class period are to have this worksheet filled out. And remember, like we talked about last week, it's not just about can you get the answers, which we call solutions. How you write it matters. Make sure it looks just like we practiced and like I'm going to show in this video. It has to look just like we've talked about. And the reason for that is these are one-step equations that we're working on, meaning you only have to do one step and then they're solved, they're done. But we want to move on to two-step equations and three-step equations. And if you're not writing this stuff the exact way I'm showing you, and in the neat way that I'm showing you, then there's no way to keep track of your work when you start working on things that take more than one step, and you'll get lost in your work, and I won't be able to read your work either. So like, I need you really in the mindset that this is more about how we write this stuff, like even more so maybe than just have the answers. So if at the end of the period, you just have a paper with the answers on it, that's really, really not what I'm looking for, okay? At the end of this, before you guys go to work on IXL skills, I am asking the substitute to collect these, and I do intend to look at them to see if you are following along through with this, seeing if you are writing things properly, and maybe we'll look at them together. I can give you some feedback on Tuesday or maybe Wednesday if I haven't had a chance to look at them yet. Okay, so the way I would like for this to work is I've broken up this paper into sections. First, we'll do questions 1 through 3, and then we're going to stop. Then we'll do questions 4 and 5, and then we'll stop. Then we'll flip the page, and we'll do questions 6, 7, 8, stop. And then we'll finish with questions 9, 10, and 11. And so for the first section, questions 1, 2, and 3, I'm going to do question 1 as an example. You're just following along, copying, and listening, making sure that your work looks exactly like mine. You've written the stuff in the exact same spot as mine. It looks neat like mine. Everything's in a straight line, the same as mine, all that good stuff. Then questions 2 and 3 are just like question 1. So I want you to just try to do questions 2 and 3 like on your own, basically just doing them the same as 1. All right, so let's do question 1. I see X is my variable. The operation that's happening to X in this one is addition. And so I want to use the opposite operation, right? I want to undo that adding of 3. And so I'm going to subtract 3. And so I'll write -3 right underneath the +3. Make sure it's right there. That's where it should be, not over by the X, not underneath the equal sign, none of that stuff. Now, the way equations work is if I subtract 3 from one side, I have to do the same thing to the other side to keep it fair. So I'll write -3 over here. And look, it's not underneath the equal sign. It's not over by the other 3. It's underneath the 10. That's where it goes. And now what happens is adding 3 to X and subtracting 3 to X, those things are like they undo each other. They cancel each other out, we like to say. And so we can cross these out. But the X remains. The X needs to be in the next line that we write. And so X will be here. I like to move it over so that it will be closer to the equal sign when I write it. Now, this part's really important. Your equal signs should be in a really straight line so that if I were to take my pencil on your paper and draw a straight line down through your equal sign, the original equal sign, it should be able to go through your other equal sign. Look, mine's not even that perfect. Mine, like this equal sign's a tiny bit more to the left than it should. See if you can get yours super straight, even straighter than mine. And then on the other side of the equal sign, we just do 10 minus 3, which is 7. And so that's our solution, X equals 7. And remember, the process that we just went through is called isolating the variable. This x is now said to be isolated because we got it all by itself, right? There's no 3 with it or anything like that anymore. So that's how we're going to handle any equation that has something being added to the variable, which is the same as question 2 is like that, and question 3 is like that. And so what I would ask the substitute that's in the room right now to do is pause the video for however long it takes, a couple minutes, whatever, for every student to be able to finish question 2 and 3. And if you could just ensure that they're writing it the same way I did. They don't necessarily have to write the word isolated on every question with an arrow. And they don't necessarily have to have this like line through the equal signs or the box or whatever, but they should have something shown on both sides of the equal sign here and their solution written the same as mine. Okay, so we're pausing. And then when you unpause, I'm going to go through the answers to 2 and 3 real quick. Okay, so I'm going to assume everybody's done questions 2 and 3. So let me just show you real quick. On this one, you should have subtracted 6 from both sides. And so that's going to make the plus 6 go away. We still have our y on this side of the equal sign. We'll bring our equal sign down, trying to keep it nice and straight. I'm still a little bit more to the left than I should be. And 15 minus 6 is 9. So our solution is y equals 9. Then on question 3, we see that our variable is being added by 12. So we're going to subtract 12 right underneath the 12. And also on the other side underneath the 20, the plus 12 and the minus 12, they cancel each other out and go away. We're left with m equals 20 minus 12 is 8. So our solution this time is m equals 8. Good. All right, so that's all the equations we have on this paper where the variable is being added. Let's go on to the next section, questions 4 and 5, where the variable is being subtracted. Now remember, the whole idea here is whatever operation you see in the equation, you just do the opposite of that. When we saw addition in these equations, we used subtraction to solve. And so on these ones where we see subtraction, we will use addition. I see that my variable a is being subtracted by 14. In order to cancel that out, I will add 14 back, but I have to do it to both sides. I'm going to write a plus 14 over here underneath the 3. Minus 14 and plus 13, 14, cancel each other out. And we get a equals 3 plus 14 is 17. Okay, this time you only have one question to do. Do question number 5 real quick. You got x minus 6 equals 8. So go ahead and pause the video for a moment. Let everybody show me their best work on question number 5 and come back, unpause it to see the answer. All right, I'm going to assume that everybody's done question 5 now. And so I hope that you added 6 to both sides. The minus 6 and the plus 6 cancel each other out. And you get x equals, let's see here, 8 plus 6 is 14. Hey, I think I said it at the start of this video, but I'm just going to emphasize it again. The way you're writing this is what this assignment is all about. If you just have a 9 here, or just a 7, or just an 8, or just a 17 or a 14, that's not good enough. It's not about, can you get the answers? It's about, are you writing this process properly? Like the process is what I need you to be learning and learning how to write. Also, make sure that all the pieces are in the right spot. Look at like where your 12s are. Are they underneath the right numbers? Do you have one in the wrong spot? Is it more left or right than it should be? You know what I mean? Like really look at the details on this. And the last thing I think I should say before we move on and flip the page is that I hope you understand what the number that we get at the end is. Like, for example, let's look at the last one we just did. The equation said there's some mystery number that we're going to call x. And if you subtract 6 from it, you get 18. And then we went through this process that we're learning, right? And we get x equals 14. What we're saying when we do that, you don't have to write this part, is that if you put this 14 where the x is, then the equation works, right? We say it's true. 14 minus 6 does equal 8. That's what we're trying to figure out, is like what number goes where x is. And this process like does it for us, right? And so if you were to check any of the other numbers we got, if you take the number and put it where the letter was, 17 minus 14 does equal 3. That's That's what we're doing. That's what you get when you solve one of these equations. All right, so we're on the back now. And this is where we got kind of rushed on Friday. So these might not be as fresh in your mind. So when you have a number right next to a letter with no other symbols between them at all, like just 3 and then X, that means you're multiplying. It's 3 times whatever number X stands for. And so just like addition and subtraction are reverses or opposite operations of each other, multiplication and division are opposite operations of each other. So in our equation, if we see multiplication happening, we use division to solve. That's what we're going to do with these next couple of questions. I see my variable being timesed by 3, and so I'm going to divide by 3. And I like to use fraction bars to represent the fact that I'm dividing. So that's what that line right there is. That line is like a fraction bar. And so what I'm saying is 3x divided by 3 using the fraction bar to mean divided by. And so I'll put a dividing fraction bar underneath 12 as well. And divide by 3 over there, well, just as well, right? If I divide by 3 on one side of the equation, I got to divide by 3 on the other side. And so what happens here is you get like a fraction with a 3 on the top and a 3 on the bottom, 3/3, right? Like if we don't even think about the x, we just got 3/3. 3/3 is equal to 1. Well, 1, we could write here. You're allowed to write 1x if you wanted to, because the 3 over 3 equals 1. But then what you'd be writing is 1 times x. And you don't need that 1, because 1 times x is just 1. So nobody writes it. So instead, we have just an x. We bring down our equal sign. And 12 divided by 3 is 4. So in this case, x equals 4. And if you tried it, right, if you put this 4 back where the x goes, 3 times 4 does indeed equal 12. All right, let's do it again. Let's pause the video for a couple minutes. Everybody try to do questions 7 and 8, just like I just did 6, because they're the same, all right? Okay, I'm going to assume the video got paused for a couple minutes and you guys did 7 and 8. Let's look at how they should have been done. In this one, your y is being times by 4. So we will divide by 4 on both sides of the equation. And what we're left with on the left side is just y. And on the other side, 20 divided by 4 is 5. So the answer to this one was 5. And if you put that 5 where that y goes, 4 times 5 is 20. And then on this one, we see our m is being times by 6. So we are going to divide by 6 on both sides, and we get m equals 18 divided by 6 is 3. All right, we got one more section to do. These last ones, all of our variables are being divided, right? Just like I was saying up here, I was using a fraction bar to mean division. That's how we write division in algebra too. We don't usually use the little division symbol. We prefer the fraction bar. So this, you should read it as x divided by 4 equals 10. This one says a divided by 5 equals 3. And this one says n divided by 2 equals 4. And so when we had multiplication in our equation, we used division to solve. Now we have division in our equation, we will use multiplication to solve. And so I like to use a little dot to mean times. I'm going to times by 4 over here and times by 4 over here as well. And the same thing happens as with when we use division and multiplication above. It's the same thing. The 4 timesing and the 4 dividing, they're going to create a 1 just like above. They go away. It'd be easier for me to explain this if I was in person. Just trust me for now, okay? They go away and you're left with just an x equals 10 times 4 is 40, okay? So can you do the same thing with a 5 over here and the same thing with the 2 over here? I'm going to go ahead and let you guys just finish up. See if you can do these ones. Oh, wait, no. You got to pause it for a couple minutes and then I'll show you the answer. So yeah, let's pause. Okay, I hope it got paused for a couple minutes. Let's go through the answers on those ones real quick. I'm going to times by 5 on both sides here and get a equals 15. And I'm going to times by 2 on both sides here and get n equals 8. All right, so now I think we can call this done. We're finished up. Let's get these collected, put them somewhere where I can find them so I can see how everybody did. I hope you did a great job on it. I hope the class period's going great. For the rest of the period, please get on IXL and let me show you what you're gonna do. Let me get out of this. Oh wait, no, I can go here. There we go, here. So last week I assigned some IXL skills from this AA category. Some of these titles, the ones that are highlighted yellow, should seem familiar. We worked on a couple of these. I think there's still a couple that nobody's completed yet, and I assigned a couple more. So a couple of these are new as of like right now. So please work on any or all of these IXL skills for the rest of the period. These ones that have AA in them, basically any of the ones that are going to have the word equation in them. Okay. All right, and I'll see you guys tomorrow.